major network goes down. Engineers rush to check the dashboards. Everything looks normal. No alert, no warnings, no failures. But traffic is collapsing across multiple regions. And the AI monitoring system reports one simple message: all systems operational. Here is the problem. The AI isn't lying, it's just confidently wrong. Because it doesn't understand what broken actually means. And by the time you might notice the gap between reality and reporting, the failure has already spread across the system. Modern networks don't look like infrastructure anymore. They behave like living systems, including cloud platforms, edge nodes, global routing layers, and automated scaling systems. Every second, millions of signals are processed, such as latency shifts, packet loss, traffic spikes, and server load changes. And instead of humans reading all of this directly, AI now interprets reality first. Companies using large-scale infrastructure systems, like those built around platforms such as Cisco systems, rely heavily on AI-driven monitoring to predict failures before humans see them. The promise is simple: detect problems early, fix them automatically, and eliminate downtime completely. But something changed quietly. Humans stopped looking at raw system behavior. They started trusting AI summaries of reality. And when that interpretation is wrong, the system doesn't just fail, it fails invisibly. The first core concept breakdown. 1. AI as a first responder. AI now reacts faster than any human team ever could. It detects anomalies instantly, reroutes traffic automatically, restarts services, and isolates nodes. It feels like the system is self-healing. But AI doesn't understand what it sees. It only recognizes patterns. A traffic spike could mean a cyber attack, a viral event, a software deployment, and a normal user growth. AI treats all of them as symptoms, even when nothing is actually broken. 2. Humans become second responders. Engineers no longer start with raw data. They start with AI-generated conclusions like cloud instability detected. But that's already a diagnosis, not evidence. So the question silently changes. It's no longer what is happening. It becomes, why did the AI think this is happening? And if that assumption is wrong, everything built on top of it becomes misaligned. 3. The fragile hybrid system. Modern infrastructure runs on 2 layers. AI equals speed, automation, and reaction. Humans equal judgment, meaning, and responsibility. This works extremely well until trust becomes blind. Because the moment humans stop questioning AI output, false certainty starts replacing real understanding, and that's where silent failures begin. The real-world failure modes. 1. Predictive routing chain reactions. AI constantly reroutes traffic to avoid congestion. On paper, this is optimization. But if the AI misreads the root cause, it may divert traffic away from healthy systems and overload backup routes instead. A small issue silently becomes a cascading failure. No dramatic crash, just gradual system collapse. 2. Automated self-healing loops. Modern systems don't wait for permission. They act immediately by restarting services, isolating nodes, and blocking traffic. But here is the danger. If the AI diagnosis is wrong, it keeps fixing the wrong thing. Each correction worsens the system state. This creates a feedback loop. Wrong detection, wrong fix, degraded system, and stronger wrong detection. The system becomes trapped inside its own assumption. 3. Cloud misdiagnosis problem. Modern infrastructures is layered: cloud provider, application layer, network routing, and edge systems. When something breaks, signals overlap, and AI doesn't always separate cause from correlation. So instead of reporting application update cause latency, it reports cloud instability detected. Now engineers chase the wrong layer. Meanwhile, the real issue spreads underneath. This kind of misattribution has been observed in large-scale multi-layer outages across systems like those in Amazon Web Services environment during complex incident chains. 4. The silent role shifting happening right now. Old world: fix broken systems. New world: question automated conclusions. Emerging roles: AI infrastructure supervisor, cloud reliability analyst, and automation failure investigators. Because this skills is no longer speed, it's recognizing when a system is confidently wrong. Here is the uncomfortable truth. AI doesn't replace engineers, it replaces uncertainty handling, but it cannot replace responsibility. Because AI doesn't understand business impact, human urgency, security intent, and real-world consequences. It only understands correlation, so a system can appear perfectly optimized and still be operationally wrong. That's why humans remain system governors, not because they are faster, but because they understand meaning. AI routes traffic. Humans decide priority when everything breaks at once, and that distinction cannot be automated safely. We are moving towards autonomous networks, systems that heal themselves, reroute themselves, and optimize themselves with minimal human input. But this creates a paradox. The more autonomous the system becomes, the more dangerous its blind spots become. Because failure will no longer look like a crash. It will look like a system working perfectly while being wrong at scale. Future roles won't focus on fixing systems. They will focus on interpreting system behavior, including AI infrastructure auditing, autonomous system oversight, and predictive failure interpretation. Because the next generation of outages won't be obvious. They will be invisible until impact is already global. So when we say network down and AI blamed the cloud, we are not talking about a bug. We're talking about misinterpretation at machine speed. Because modern networks don't just fail physical anymore. They fail logically. And when AI becomes the voice of truth inside infrastructure, the real danger isn't downtime. It's false confidence at scale. If you want more breakdowns like this, covering AI systems, cloud failures, and hidden infrastructure risks, subscribe. And comment this: should AI be allowed to auto-correct critical systems without human approval? Or does that guarantee silent failures at scale?